Hello YouTube. In today's video, I'm going to be discussing audio rate modulation and its plethora of applications. So I'm just going to try and cover as many of them as I can. And I feel like FM is one of my favorite forms of sound design because it can be very unpredictable. And that way you end up with a lot of happy accidents. And that just increases your chances at finding something fantastic. So without any further ado, let's get into it. Right, I've got myself an initialized Serum 2 here. We'll start off going over the actual inbuilt FM modes. If I switch this to a sine wave to start off with, switch this other one to a sine wave also, and then go FM from B. If I turn down the level of oscillator B and then slowly turn up the FM on maybe like a 1-bar ramp, then you'll be able to hear as more harmonics get introduced. And the way this is working is that the frequency of this sine wave is affecting the frequency of this other sine wave. So if I slow this way down, then you'll be able to hear just a wobble. That is because this is now at a much slower rate and can be heard as more of an LFO, because pitch and rhythm are the same thing, just at very different speeds. So what happens is as I turn the octave up to match the frequency of the first oscillator, we actually get extra harmonics introduced rather than this pitching LFO. And that's because the pitch differences are happening so fast that it's actually changing the pitch during this cycle and therefore is adding extra harmonics. And if I increase this to a higher octave, then this modulator is going to be oscillating twice as fast as this carrier, and therefore the harmonics that are introduced are even greater. And that effect gets exaggerated the higher we go. And we have another mode, which is phase distortion here. And this is a much softer effect, but has a very similar concept because it's still affecting the pitch in a way. What's happening, the phase knob, the starting point of this waveform, is being modulated at audio rate. As it's being scrubbed forwards, it's essentially like speeding up the oscillation and gives us a very similar effect to pitching up. But the phase distortion is definitely not as sharp as actual FM. You can achieve similar effects by actually just modulating the phase or the coarse pitch using oscillators. So you can get that audio rate modulation on these parameters on your own. And that way you can choose amounts in a very different way. For an example, we have this warp turned off now. If I just go on the phase and go mod source, oscillators, oscillator B, and then go into the matrix, and maybe if I just have it going one direction. As you can see, just by modulating the phase, we're getting a similar effect. And then if we want something that's more sharp, I'll remove this modulator and I'll attach it onto the coarse pitch instead. Mod source, oscillators, oscillator B, and then go into the matrix again so I can control the amounts. And again, it's going to be very different to the actual FM here as well. And then to further change the tone of the standard FMs, if I remove this pitch modulation once again and go back onto just FM, let's just drop this modulator an octave. If I put a ramp back on this FM and take it somewhere like halfway, right? And then go into this global tab and select ultra quality, then it's going to change the way that the FM is sounding. You can hear how it's a lot sharper. And as well, with Serum 2, we have these new modes for FM. So we've got through 0, which is the standard, and then we've got exponential, which gives us a different tone. We've also got the linear, which gives us a very different tone because what happens is it only does a positive side of the waveform. So you get a very wonky FM sound, but it can also have its uses as well. Okay, to show that there's different ways of doing this, I'll get a LFO now and show you what happens if you just assign an LFO onto the pitch, or let's say phase or something like that. Let's just go all the way. And this is a really interesting way to look at FM. If you get this kind of rounded pitch up, set this envelope to retrig, you can hear that like water droplet quality. And then if I speed this up, you can hear how that droplet quality is retained. But when it gets to audio rate, let's just set this to our fundamental, which is 43 hertz in our case, then we just get that bubbly quality, but as more of an FM effect. And then changing the range of this pitch is going to change the tone as well. And then as well, changing the shape is going to give us different effects. So now what happens if we do the opposite, right? So if I go back to a slow rate and then do this pitching down, for this example, let's just do unipolar. You get this kind of laser gun shot. And then as I start pitching this up, you keep that lasery quality, but again, it just gets faster and faster until, let's go 43 hertz. We've got a FM tone that has a lasery quality in it. Let's try this with a saw wave. So yeah, pitching down gives you this kind of lasery quality, whereas pitching up gives you this bubbly quality. Yeah, it can be very informative playing with these LFOs because you can just go through so many shapes so quickly. Go to a different waveform. Nice sine. And that way you can generate so many FM tones. And then let's go over some more complicated FM for some more unpredictable results. Let's go back to our oscillator. And what's really fun to do is FMing a sine wave by a more complicated wave. So if I go FM from B on this, which has got our usual sine wave, but now if I add some distortion onto this wave, maybe sine fold, and then some bend plus minus. Change the octave of this. Right? And we're getting so many awesome tones out of this. When you're trying to make more stable FM tones as well, it's a good idea to turn the random phase all the way down. Right? And then if I drop it a few percent, just 1%, different results with just each percentage. So many options with this. And then to change the tone, we can just change the phase of either the modulator or the carrier. And you're getting different tones again. And in Serum 2, we've got the addition of these different pitch modes. And if you go on to harmonics or ratio, it can achieve really satisfying results with these FM type sounds because the modulator will always be related to the fundamental in some way. Let's go on to the ratio mode. So yeah, you can get some really satisfying results out of that. I'm now going to move on to some other concepts using FM to control other things in the synth, right? So for example, let's just get a nice table of tones here by just going a 1 bar LFO on the FM, then just resampling that to oscillator C. And yeah, let's just see what we got here. Right, so we got some good tones there. And so what we can do now is maybe attach a filter, open up this first oscillator, turn the level down, turn the FM off, and use this first sine wave to control this filter. So if I put oscillator C through the filter, go mod source, oscillators, oscillator A, and then we're getting some interesting audio rate texture coming from that. And then I can adjust the texture of this by changing the amounts. Maybe change it to bipolar. Using audio rate modulation, we can basically use it as a mod source for anything within this synthesizer. So we could go into the effects and maybe have some distortion. Let's go with like line fold, something really aggressive. But we can use FM. Let's just go with a re-triggered audio rate one on an LFO. Let's go 43 Hertz. And we can use this as almost like an audio rate on off switch. So let's say if we only want distortion at half of the waveform cycle. So I can have it kick in and have it so that the mix of the distortion only comes in after about halfway through the waveform. So that way we're actually reducing the amount of grit that's in the sound by half. And this concept can be applied to various different things. You know, maybe we want part of this wave cycle to be more bright. Or maybe we want it to be darker when the distortion is in. And this can be used for anything, you know, like you could maybe use some comb filtering. Let's go onto the comb, give it some resonance, make it the same frequency as our fundamental. Right, put it before this distortion. And then what I'll do is I'll have the resonance attached onto our audio rate LFO. For science, let's just take this LFO and double the frequency. So everything happens twice as many times in a cycle. So we've got no distortion through here. And then the second quarter has distortion, no distortion once again, and finally more distortion. So all of this is happening so quickly within this wave cycle. And then, yeah, let's just add on another filter just to top this sound off and just make it actually a bit more usable. Let's have it open up over the course of a bar. And then I'll just add on a delay. And actually, you know what? Maybe I'll have this a half bar. And then set this to a dotted eighth ping pong delay and set a good range with some nice amount of mix. Maybe actually let's have this be a quarter and let's shrink the MIDI way down to a quarter. And then change this octave to an octave higher so the filter's also doing quicker modulation. Maybe even quicker. Right. And then let's add some more distortion on the end just to bring it out a bit more. Let's go asim. Convolver, long spaces, crisp. Bring the size up, but the decay way down. maybe more mix, and then finally just cut off any unwanted low frequencies. Right, I can just record that out and we have a interesting effect. I hope that made it a bit clearer of what FM is doing and also the applications for it. If you want to support the channel, you know what to do. And I'll see you on the next video.